Okay, this is problem 2. Again, our task is to solve for matrix A. This time we have a multiplication problem here. There is no division per se. So what we need is the inverse of this. So if we can get the inverse of this matrix, I'll just call this B just for a minute. If we can get B inverse and then multiply that times B and then multiply that times A and do the same thing over here, B inverse times this matrix here, 1, 1, 3, 2. This bit will be I, and I times A is going to be A, and that will give us our answer. So in order to solve for A, we basically need the inverse of this matrix, and we're going to put it in front of this one. So let's see if we can do that. A is going to be, now the inverse of this matrix. And again, we have to multiply on the left here, because we're going to be multiplying on the left side of this equation here. We have to multiply on the left side of this side. Okay, the inverse of a matrix. Remember how to do this. We swap these two, 4, 1. We make these their opposites, so that's -2 and +1. And then we divide everything by the determinant. So let's see, this is 4, and that's -2, 4, but we have to subtract the -2. 4 minus -2 is 6. So if we could carry out this multiplication, we should have matrix A figured out. Okay, so let's see. Matrix A. It's going to be a 2 by 2, right? This is 2 by 2, this is 2 by 2. So we just need to have these 4 little components here. And we can get that by doing rows and columns. So let's see. So this is 4/6 minus 6/6. And so 4/6 take away 6/6 is minus 2/6. So that's what goes here. Minus 2/6. And yeah, we could write that as minus 1/3 if we wanted to. Okay. Let's see if we can tilt this just a bit. And first row, second column. So this is 4/6 take away 4/6, that's 0. And then second row, first column. So this is 1/6 and 3/6, that's 1 and 3 is 4/6. And yeah, we could write that as 2/3 if we wanted to. And then for the last slot, second row, second column. So that's 1/6 and 2/6 is 3/6. So that's going to be my answer for A. If I wanted to clean that up a little bit, I could. Let's see, A is going to be -1/3, 0, 2/3, and 1/2. If I had time on a test, I might want to check this just to make sure it works. So the claim is that if I have this original matrix, 1, 2, -1, 4, and I multiply it times A, this is plugging it back in like we would in check a linear equation, -1/3, 0, 2/3, and 1/2. We're supposed to get 1, 1, 3, 2. So this is just a check to make sure that we got it done right. So let's see. This is minus 1/3 plus 4/3. So 4/3 minus 1/3 is 3/3, and that's right. That's 0, and that's 1, that's right. Second row, first column, that's 1/3 and 6/3. So 1/3 and, sorry, I can't multiply. This is 1/3 and 8/3. 1 and 8 is 9/3. 9/3 is 3, so that's right. And then second row, second column, that's 0, and that's 2, and that's good. Okay, so it does check. Everything works out fine. We had solved for A. Problem 3 coming up.